Okay, we're going to do 9.3, which is arcs and chords. First you need to do the 9.2 warm-up, and then we'll get on with this. Okay, so we're going to just do relationships between the arcs and chords, and the first part of this is really easy, but then the second part gets a little bit trickier, but that should all be in your notes. So the first theorem is that in the same circle or in congruent circles, two minor arcs are congruent if and only if the corresponding chords are congruent. So if FG and JH are the same length, then you know that the arcs, yeah, I can't draw, FG and JH are also the same length. And then the converse is also true. If the arcs are equal measures, then your chords are as well. So in this it says a circular piece of jade is hung from a chain by two wires wrapped around the stone. JM and KL are congruent chords. Okay, and they mark that. And KL, the arc, is 90. So then you need to find JM. Well, if KL is 90, then JM is also 90. All right, so you can do this one. The chords are equal measures, so arc RS is 85, so therefore arc TV is also 85. Okay, on this one, it says the arcs are congruent, so it tells you arc WX and arc YZ are congruent measures. Therefore, we know that the chords are equal. So we need to find the length of chord WX. So since they're equal, we will set 7x minus 2 equal to 5x plus 6. I'll subtract 5x and get 2x. I'll add 2 and get 8. And I get that x equals 4. Since it wants you to find WX, then you'll just plug that in. So 7 times 4 is 28, and 28 minus 2 is 26. So that's your answer. And since they're equal lengths, you could have plugged it into here as well and got 26. Okay, you can try this one. The arcs are congruent, and so you just need to set the chord lengths equal to each other, solve for x, and then plug it back in to find the length of LM. Should have gotten 13. Okay, these theorems are actually easy to forget how to work them. So if I'm going to put emphasis on anything, it's going to be theorems 9.3 and 9.4. So it says if a diameter or radius of a circle is perpendicular to a chord, then it bisects the chord and its arc. Okay, so if this is perpendicular, it means this length is equal to this length, and this length is equal to this length. Okay, and likewise, this is just the converse. It says the perpendicular bisector of a chord is going to be the radius or the diameter of the circle. So if there's a chord and they're equal lengths with a perpendicular line drawn through it, then you know that that line is going to be a radius or a diameter. So it says in circle G, measure of arc DEF is 150. So this whole big long arc is 150. So you need to find the measure of arc DE. Well, you have a perpendicular bisector in here, so you know that DE is just half of 150, so 75. This is very similar. You have the arc WUX as 160, and you have a perpendicular bisector in there. So then just find the length of UX. Should be 80. All right, this is where it gets a little tricky. So it says in the ceramic stepping stone below, diameter AB is 18 inches long, and chord EF, it's right here, is 8 inches long. So we have to find CD. So we're finding from the center to here. I should use almost different colors, but I don't know if anything will show up. So what you're going to do is you are going to draw a line from C to E, and that's a radius. And we know that this diameter is 18 inches long, so this radius is 9. And then the chord EF is 8 inches. Well, we know this perpendicular line bisects it. So this part of it is 4, and this part of it is 4. We're just going to look at this triangle, however, and we need to find this angle. Well, this is a right triangle. We know the hypotenuse is 9 and one of the legs is 4. I think I said we need to find this angle, but I meant we need to find this side. Okay, so I'm just going to go ahead and use the Pythagorean theorem to figure this out. A squared plus b squared equals c squared. Remember, c is always your hypotenuse, so it's 9 squared, or 81. And then one of your legs is 4 squared, so I'll go a squared plus 16. And then we'll just solve for a. So I'm going to subtract 16, and I get 65. So then I take the square root of both sides, and I have a equals the square root of 65. And you can definitely put that in your calculator and get an approximation. It should be 8 point something, probably. It'll tell me. Maybe, eventually. Yep, 8.06, or a square root of 65. Okay, you can pause this and try to do it yourself, but I'm going to go ahead and solve it since this figure is a little easier to see without the stepping stone designs. So it says that QS, the whole diameter, is 14 inches long. So if I draw a line from V to R, I know that that's going to be 7 because that's a radius and the diameter is 14. The chord RT is 10, so just from R to U is going to be 5. And then we have this right triangle here, and we're going to solve for this, which I'll just label A. So we'll have A squared plus 5 squared, which I'll write as 25, equals 7 squared, or 49. So then I will subtract 25 from both sides, and I get 24. And when I take the square root of 24, I think I get 4.9. Yep. Okay, another theorem is if you have a circle where two chords are congruent, then they're equidistant from the center. So this also is itself and the converse. If the chords are congruent, then they must be equidistant from the center. And remember that the distance between a point and a line is going to be perpendicular. Okay? And then also, if you have two chords that are perpendicular from the center that are the same length, then you know that the chords are also the same length. So let's apply that. It says in circle P, EF and GH are both 24. So we're supposed to find PQ. Well, if EF and GQ are 24, that they're equal, then we know that the distance here, these perpendicular lines, are going to be equal. So we're just going to set 4x minus 3 equal to 2x plus 3. I'm going to add 3 and get 6, subtract 2x and get 2x, and then I get x equals 3. But we have to find PQ, so we're just going to plug it right in. So 2 times 3 is 6, plus 3 is 9. And again, you can plug it into whichever one you want because they are the same length. Okay, you can pause this if you want and try it. I'll go ahead and do it. We have 2 chords that are the same length. They're each 29. And we have 3x minus 6 equals x plus 8. So I get 2x equals 14, or x equals 7. And then I'm going to plug it in. 7 plus 8 is 15. And that's it. Your assignment is page 665. 7 through 23 all.